Hello friends, hope and my dear students, hope you are safe at your places and stay home, stay safe and healthy. Okay. So in the last session we have discussed about the numericals related to the finite and infinite life with the help of SN curve and the derating factors. So today we are going to discuss about Soderberg and Goodman lines, which is also the prominent topic or prominent area of this particular unit 2 of Design of Machine Element 2 in the 6th semester of 3rd year of Rajasthan Technical University Mechanical Engineering students curriculum. Okay, so let's get it started. As you can see in the picture that the stress amplitude is going to be plotted on ordinate, okay, and the mean stress is going to be plotted on abscissa. Okay, means mean stress should be plotted on x-axis and stress amplitude should be plotted on ordinate, which is called as y-axis. Okay, so in this way, if you will plot these magnitudes, either stress or stress amplitude or mean stress, then you will get the diagram like this. Okay, where if you will connect the point or connect the line of SE, which is endurance limit, with SYT, which is also called as strength or yield strength or yield tensile strength, okay, then you will get a line which is called as Soderberg line. Clear? Next is Goodman line. If you will connect same SE point with SUT, which is ultimate tensile strength, okay, then this line will be called as Goodman line. Next is if you will connect it by a parabola, the same SUT and SE, this is called as Gerber line or Gerber's parabola in the picture. Okay, so these are the three lines which are called as deciding factors or deciding factors for any kind of material under fluctuating stresses. Okay, so these are the failure points. This is the yield line. If you are connecting SYT with SYT, this is called as yield line. Okay, so on the basis of these principles or these equations, you may say that this particular material will be under subjected to the fluctuating stresses. This will sustain or not, in which Gerber parabola fits the failure point of the test data the best possible way. Means this is the best possible way to fit the failure point datas. Okay, after that let's see that how we can calculate the equations of these these lines and parabola. We will apply the following formula of equation of a straight line: x by a plus y by b equals to 1. Just note keep this picture in your mind so that you can correlate. For applying the above formula in the equation of Soderberg, it will look like this: sigma m by s by t, means on the x-axis there is sigma m, on the y-axis there is sigma a, and the intercept of Soderberg line on x-axis is what? S by t. Let's see. As you can see the Soderberg line, the intercept of Soderberg line on sigma m is s by t, while on sigma a intercept is se. So your equation will look like sigma m by s by t plus sigma a by se. Okay. Similarly for the Goodman line, it is only here it will be same because on the y-axis the point is same, so intercept is same, while sigma m by sut, which is a change in the Goodman line. If you will see the graph, that on the x-axis it is SUT instead of SYT. So in those two lines only this is the change. So keep these two things in the mind so that you can not forget. Okay, basically the Goodman line is the safe from design consideration because it is completely inside the failure point of test data. Means this is the most safest part, means you will get highest dimensions, means the dimensions may be larger but it is safe. The equation of a straight line is simple compared with the equation of parabolic curve, which is there in the Gerber parabola. So it is not necessary to construct a scale diagram or rough sketch. It is enough to construct the fatigue diagram. So let's see some numerical, then we will try to solve it out. For the infinite life problem, it is given that there is a cantilever beam made of cold drawn steel. If its steel is given and SUT is given, then you can simply calculate the value of SE dash, which is 0.5 times of SUT, and you can calculate the value of Ka, Kb, Kc and Kd. On the basis of that you can calculate the value of Se, which is called as corrected endurance strength. Okay, if you got the corrected endurance strength, then you just plot this particular diagram and after plotting the diagram you may apply the equation AB. Okay, AB is this equation AB, which is called as Soderberg line, but this is modified Soderberg line, you can see. Okay, if you will plot this equation, then you will solve the desired value, or you will get the value of SA and SM, and after that you can calculate the diameter of beam by putting the value of SA and SM in this particular equation. Okay, in this way you can solve this particular numerical. Similarly, you can also try these numericals. These are the same, and if assumptions are there, means if you are going to apply any kind of assumptions, then you may apply assumption or assume the distortion energy theory as a theory of failure in this particular term. So meanwhile, we will also discuss what are the parameters related with the Gerber's parabola, or which one is most suitable for materials subjected to fluctuating stresses, that we will encounter in upcoming sessions. So meanwhile, just stay tuned with our Engineering College Banswara YouTube channel for more such updates about different branches of engineering like mechanical engineering, civil engineering, computer science engineering, as well as electrical engineering. Thank you so much. Just stay tuned.